Good morning, good people. My name is Hendrik Makaneta, and of course, today I'm going to teach mathematics, grade 9. And of course, I am from the STEM Lockdown Digital School. And I hope that this lesson today will be exciting and probably benefit the learners who are probably listening from different corners of our land. The subject, as I've already indicated, is grade 9 mathematics. And of course, if you want to reach me out on the Twitter account, you can do so at Hendrik Makane 3. And of course, I will be able to respond to some of the questions that you may have. And we are proceeding with the topic of the day. And the topic that we are going to talk about relates to geometric problems. And I believe that by the end of this lesson, we should be able to solve geometric problems which involves unknown sides and of course unknown angles in triangles, as well as using known properties. But equally, we also want to look at the properties of similar triangles, as we have already started last week, just to end the topic. Then, of course, our next slide, I just want to list the conditions of similarity again. We should know by now that two triangles are similar if they are equiangular. In other words, when they've got corresponding pairs of equal angles. That is the first condition that we have spoken about last week in our previous lesson, that all angles must be equal. If you have got triangle ABC and triangle DEF, corresponding angles there must be equal in order to conclude that the two triangles are similar. But of course, the other condition is to look at the sides. That are the sides in proportion. If the sides are in proportion, then that will be the second condition. Of course, the second condition can be derived from the first. Once you have managed to prove that the angles are equal, once you have been able to prove similarity, then you can make a conclusion that the sides are in proportion. Without any waste of time, we must also look, as we carry on, we must also understand the notation of similar triangles. This is very important. The notation of similar triangles is very important in a sense that it gives you a clear picture of corresponding angles as well as sides. You cannot just name your angle, without using the correct notation. And this, of course, means that whenever you have a triangle ABC and you say that it is similar to triangle DEF, this means angle A must be equal to angle D, and then angle B must be equal to angle E, and lastly, angle C must be equal to angle F. So the notation there is very, very, very important. Look at the notation and make sure that you correctly put it, in accordance with the notation. I'm going to give you two triangles. I am going to give you two triangles. And the first triangle is triangle ABC. Please bear with me there. I see that the word C does not appear in the first triangle or the letter C. And of course, the second one is triangle DEF. These two triangles also have angles. If you look at angle A, for instance, in this case, angle A is equal to angle D. That is the information that is given. Always make sure that whenever you answer a question, look at the given sides as well as the given angles, or look at the information that is given. Now, we've already said that angle A is equal to angle D. And as I've said, this is the information that is given, and equally, at the same time, angle B is equal to angle E. You can see the hashtag there, the hashtag sign. Angle B is equal to angle E. And of course, angle C is also equal to angle F. So you can see that these two triangles are equiangular. And what conclusion can we make from equiangular triangles? The conclusion that we can make in this case is that triangle ABC is similar to triangle DEF because they are equiangular triangles. They have got a set or pairs of equal angles. As I've said, angle A is equal to angle D, angle B is equal to angle E, and of course angle A there, angle C in fact, as already said that the last part here should be C, the letter C does not appear there. It should be equal to angle F. And this of course means that the two triangles are equiangular, meaning that they've got three pairs of equal angles. That is what we mean by the word equiangular. So they've got sets of equal angles. But it doesn't end there. That does not end there. You also need to look at the sides. If you look at the side AB, you can see that there's a line, this line here. This line looks exactly like this line here. In fact, this short line here means that this side AB is equal to the side DE. That is what it means. The line AB is equal to the line, sorry, that's not equal, it's in proportion, sorry, excuse me there. The only things that are equal here are the angles. Please look at the triangles. of course, you can see this is the bigger triangle and this is the smaller triangle. So the line AB is not equal to DE, but it is in proportion to the line DE. I just wanted to correct that. So the line AB is proportional to the line DE. And similarly, the line AC is also in proportion with the line DF. And lastly, the line BC is in proportion with the line EF. That is what I wanted to talk about in as far as these two triangles are concerned. And of course, they represent similarity. You can see that they look similar. They are similar. And we say that two triangles are similar if and only if they've got the same shape, but different size. So you can see the size is not the same. The size of ABC is not the same as that of DEF, but the shape is exactly the same. I thought that it is important for us to look at the two triangles. We are now going to proceed to the next slide, where you can see that the correct notation is very, very important when naming the similarity between triangles. So the next slide is talking directly to the previous slide, where you are able to see that we have managed to use the correct notation when naming the similarity between triangles. For example, the notation for the triangles in the previous slide should be written as follows. Firstly, you need to say triangle ABC is similar to triangle DEF, because it indicates that angle A is equal to angle D, angle B is equal to angle E, angle C is equal to angle F. And of course, the lines AB is in proportion with the line DE. What does this mean? This means that when you take AB and divide that by DE, you should be able to get the same answer when you equate that to BC over EF. And of course, when you also equate that to the line AC over DF. That is why we're saying those lines A, B, and DE are in proportion. BC and EF are also in proportion. And AC and DF are in proportion, as you can exactly see in our diagram. Why? How do we know that the lines are in proportion? How do we know that AB is in proportion to DE? That's because it is given. The information is given there. How do we know BC is in proportion to EF? It's also given. And of course, the same goes for AC. AC as well as DF. They too are in proportion. I hope that the slides are able to assist. And of course, that is where we draw this conclusion. And of course, in our next activity, the second activity, I want us to study the figure below and thereafter answer the questions that will follow. So let's study the figure. Let's look at this figure. We need to study this figure, and thereafter we will be able to answer the questions. Let's carry on now. Maybe let's make it bigger. Let's go to the next slide and just enlarge our figure here. I'm sure that it is bigger now. We have got a triangle there. If you can look at the figure, we have triangle ABC. I'm sure that everyone can see this triangle. And of course, there's a line that cuts the triangle. And that line is PQ. It joins, it cuts the line BC and the line AC at the point P and Q respectively. But of course, we are also given information here. We are given information that the line AB is parallel to the line PQ. This is information that is given. The line AB, as you can see there, is parallel to the line PQ. And what does this mean? This means that we can use the properties of parallel lines or parallelograms to look at the equal angles. For example, you can already see here that there are some equal angles, which are also known as corresponding angles. If you look at angle A, what is the corresponding angle that is equal to angle A? Obviously, because of the two parallel lines, you can see that angle A is going to be equal to angle CPQ. That is what it means. Angle A is equal to angle CPQ. But equally, angle B is going to be equal to angle PQC. Those are corresponding angles. Those are corresponding angles. So if you can look at this bigger triangle, ABC, you can also see that there's a smaller triangle, which is CPQ, which is formed by joining the line P and the 2 points P and Q respectively. If you join that line, which is a parallel line, it forms a second triangle. So now you can prove similarity between the two triangles, because you also have angle C, which is common in both triangles. If you look at the bigger triangle and the smaller triangle, and we are going to explain it. We are going to explain it now. And how do we explain it? We are going to explain it as follows. This will be in the form of questions. Now that we have studied the triangle, we need to prove that triangle ABC is similar to triangle PQC. That is the first point. And of course, the second one will come to that, where you need to calculate the length of AB. So going back to our triangle, or the two triangles, we need to prove that triangle ABC is similar to triangle PQC. That is the most important thing that we need to do. If I can take you back just to reflect, I hope that you have drawn the sketch somewhere in your paper, but let me take you back to the sketch where we need to prove that triangle ABC is similar to triangle PQC. So we are proving similarity. And how are we going to prove it? I've already told you that triangle ABC and triangle PQC have got a set of equal angles. If you look at angle A, this is equal to angle CPQ, as we have said, and those are corresponding angles. And of course, angle B is equal to angle PQC. Those are also corresponding angles. And the last set really will be angle C. If you look at angle C, it is common in both triangles. I think that the most important thing in answering this question is that you need to separate the two triangles so that you can see exactly what you are referring to. So in other words, you can draw just one triangle, the bigger triangle, which is ABC. And the smaller triangle will be PQC. Once you have drawn these triangles, you will see that angle A will be equal to angle P in the small triangle, and angle B will be equal to angle Q in the second triangle, and of course angle C is equal to angle C, even if you had to separate them. Why? Because of the parallel lines. And what conclusion can we make when two triangles have got pairs of equal angles? What is the conclusion that we can make? The conclusion that we can make or deduce from this activity is that triangle ABC is similar to triangle PQC. And what is the reason for this? The reason for this is that the two triangles are equiangular, meaning that the pairs of angles in the two triangles are equal. And that has been shown by stating that A is equal to angle CPQ, angle B is equal to PQC, and angle C is equal to angle C because it appears in both triangles. Now, what is important is that we need to also look at what is given in terms of the sides. So basically, we've been able to prove that the two triangles ABC is similar to PQC. Triangle ABC is similar to triangle PQC. Reason, the two triangles are equiangular. Now what we need to do is to calculate the length of AB. We now need to calculate the length of triangle of side AB. If AC is given as 10 units and PC is given as 4 units and PQ as 2 units. So basically we are given 3 sides. We are given AC, PC, and PQ. And we are told that we must find the length of AB. So you need to understand the length AB from this particular activity. That is the base of triangle ABC. If you were to rotate it 180 degrees clockwise, you'll see that the side AB will be the base of your triangle, and that is the side that we need to to find. Now, we have already proved that the two triangles are equiangular, meaning that they are now similar. So if the two triangles are similar, if triangle ABC is similar to triangle PQC, then you should know that AB is in proportion with PQ, and BC is in proportion with QC, and AC will be in proportion with PC. So this means you can write AB over PQ will be equal to BC over QC, which in turn will be equal to AC over PC. And remember, you are given the value of AC. You are also given the value of a PC, which is 4 units. And equally, you are given the value of PQ. So now that you have got values, all that you need to do is just to substitute. So you can be able to substitute your values at this point. And let's see how I'm going to substitute. But before we substitute, you can see the solution of how we have proved that triangle ABC is similar to triangle PQC, just as reflected in the next slide. Before we go to prove or to find the value of AB, you can just see that what we have spoken about in terms of proving similarity. You can see that in triangle ABC and PQC, angle C is common, as I've said. The angle C is equal to angle C because the two angles are common. And angle ABC is equal to angle PQC. Those are corresponding angles because the line AB is parallel to the line PQ. Equally, angle BAP is equal to angle QPC. That is also, those are corresponding angles. That is why we have concluded that triangle ABC is similar to triangle PQC. So that will be your answer for your similarity there. The reason is AAA, angle, angle, angle. So that they've got equiangular conclusion there. And of course, coming back to what we were about to prove now, we were about to prove that, or to solve, to find the value of line AB. How do we find this value of line AB? You need to understand that since the two triangles are similar, then in triangle ABC and triangle PQC, as I've said earlier on, AB over PQ, because AB is in proportion with PQ, you'll say AB over PQ is equal to BC over QC. And this in turn is equal to AC over PC. Remember, you are given the side PQ, which is 2. You are also given the side AC. Because remember, if we go back, you are given AC, which is 10 units, and you are given PC, which is 4 units as well. So those are the sides that you can use. Make use of the available sides. You should be able to use AC, PC, and PQ. To conclude that AB over PQ is equal to AC over PC. So the value of AC is 10, and the value of PC is 4. And of course, you multiply both sides, the right-hand side by 4, the left-hand side by 4, that over 2, and then you also do the same with the right-hand side. You multiply by 4 over 2. And of course, 4AB is equal to 20. This means that AB will be equal to 5 units. But remember the importance of using the available information to find the missing site. So the available information that we have there is just 3 sites that are given. And making use of these 3 sites, we were able to find now the missing site. And of course, this concludes our 2 questions, that of proving that triangle ABC is similar to triangle PQC. And in the same note where we calculated the length of AB. So basically, these are the 2 triangles that we have managed to work with, where we were able to prove similarity. ABC as well as PQC. And that concludes our intention to solve similarity there, just to prove that the 2 triangles are similar, and also to find the missing side using proportion. It should be clear at this point that we've managed to prove a similarity, and that we've managed to calculate the length of AB. When you are given AC, which is 10 units, PC being 4 units, PQ being 2 units. And that should be clear as of now, in as far as similarity is concerned. But right now, I want us to go to the next activity. Now that we've managed to prove with by giving statements and reason, I want us to go to activity 3, which will conclude our lesson. We are going to conclude our lesson with the next activity, where we are able to reinforce our understanding in as far as this topic is concerned. And I think that it will close the topic on similarity today, as we carry on with straight lines tomorrow, the geometry of straight lines. Let us now proceed to the next slide, where we will be given activity 3. The next slide will be able to give us the next activity, which will be called activity 3. And in this case, we are now going to use the properties of similar triangles to find unknown sides. In this case, you will have to calculate the length of PS if triangle ABC is similar to triangle PTS. So we are basically given the 2 triangles, triangle ABC as well as triangle PTS. And what must we prove? We must calculate the length of the side PS using the information that is given. So meaning that we are carrying on with the properties of similar triangles. And let us zoom directly into the next slide, where we will be able to calculate the length of PS. Let's look at the two triangles first. It's very important to observe the two triangles and to see what is given there. Excuse me. Right, we have got triangle ABC and triangle PTS. Triangle ABC and triangle PTS. And you can see there that we are given some sides and some angles. In triangle ABC, angle B is equal to angle T in triangle PTS, both of which are 76 degrees. Angle C is equal to angle S, both of which are 45 degrees. So obviously, you've got two pairs of equal angles. This means automatically the last angle A is going to be equal to angle P. We know this because we are already given the information that the two triangles are similar. Now, how do we find the missing side? How do we find the missing side? You need to calculate the value now of PS, which is given now as X. And how are you going to find that value? Remember that since you have got two sets of angles which are equal, C equal to S, and then B equal to T, this tells you that AB is in proportion to PT. AB is in proportion to PT, and AC is in proportion to PS. You can see that already. So this means you are going to now equate AB over PT will be equal to AC over PS in order to find that missing side. And from there, really, you can just do your calculations. You can find now the value of X as reflected in the example that follows. In the answer that follows here, you can see that as I've just said to you, AB over PT is equal to BC over TS, which in turn is equal to AC over PS. The reason you are given that triangle ABC is similar to triangle PTS. That is information that you have already. Now, you should be able to use the given information to find the unknown. And the unknown in this case will be your X value. And of course, since AB is in proportion to PT, BC in proportion to TC, and AC in proportion to PS, you can then substitute the values there. The correct value there, as we said, it will be 6 divided by 2. And this, of course, is equal to 12 over X. And as you solve, when you have got 6 over 2 and 12 over X, even by inspection, you can see that your X value there will be 4. But of course, if you solve it, you multiply both sides by 2. You will see that if you multiply by 2x both sides, the left-hand side will be left with 6x and the right-hand side 24. And of course, when you divide both sides by 6, you will see that 24 divided by 6 gives you 4. And of course, the last one will be your x value, which we have found. And of course, that actually brings us to the conclusion of the third activity, which I believe you will give you a chance to solve the next homework without any problem. And of course, your next homework is as follows. You need to study the figure, which is below, and answer the questions that will follow. In this figure here, I've got 2 questions for you. You need to prove, firstly, that a triangle PQM is similar to triangle SRM. And B, you need to calculate the lengths of PM and PQ. Now, you can already see that we have got 2 parallel lines, PQ and RS. Those 2 lines are parallel. And we are also given that the line MQ is 72 millimeters, MS is 42 millimeters, and RS 70 millimeters, and of course MR 56. So once you have proved that the 2 triangles PQM is similar to SRM, then you can use the available sides to calculate the length of PM and PQ, meaning that the sides will be in proportion. You will have a set of sides which are in proportion, and this should be enough to help you to do this particular homework. I repeat, first things first, just study the diagram and prove that triangle PQM is similar to triangle SRM. Thereafter, calculate the length of PM and PQ. And of course, this should be able to help you once you have proved a similarity. You cannot do B without doing A first. You can't do B without doing A first. And of course, you can visit our links, which we have shared initially, just for additional work. Let me also take this opportunity to invite you to our next lesson, where we will be able to learn more about the geometry of straight lines. We will be able to learn more about the geometry of straight lines in our next lesson, which will take place on Tuesday, the 21st of April. And I hope that you were able to gain much better from the lesson of today, this morning. Once again, remember to send me a WhatsApp message if you have got any additional questions regarding today's lesson, or perhaps the homework. You can WhatsApp me on 082 623-2148 or makaneta.hm@gmail.com. Our social media pages, Twitter account @Africa Teen Geeks. We are also on Facebook, Africa Teen Geeks. And of course, our sponsors as well. We want to thank them. The Sasol Foundation, in partnership with the STEM Champions and MS Zora, together with the Department of Basic Education, for making this lesson possible. Until we meet in our next lesson tomorrow, thank you very much indeed and have a great day.